Here we have a couple of questions involving differentiation with indices and algebraic fractions. So we've got one here where we have y is equal to 3 over x squared, and another one here where we have an algebraic fraction here with 3x cubed and a bracket with x squared minus 4x all over the value of x. So I'll go through a method on how to solve both of these type of questions. So you know the general rule for differentiation, providing our expression is in the form of y equals ax to the power n, then we can differentiate such that we would have a multiplied by n, which is our power, times x to 1 less than the power, so it's n to the minus 1. That's the general form. As long as we get into this form, we can differentiate our expression. There are a couple of special cases which you should be aware of. That if you have y equals ax, so just a number multiplied by x, the power being 1 here, the value is just a here, so dy by dx is just equal to a. And the other one would be if y is equal to a, so y is equal to a constant number, then it just disappears. When we differentiate, we get the value of 0. So here's our first question, or first expression. We have y equals 3 over x squared. Now, to differentiate it, we are going to need to put this into a form that we know how to differentiate, so we need to make it become something like y equals ax to the n. To do this, you need to know one of your rules of indices, which is this one here, that if we have 1 over x to the n, then that is equal to x to the minus n. So we can rearrange this expression up here quite nicely now. We can say, well, that will just become y equals 3x to the minus 2. It is now in the form that I know how to differentiate. So now I can go straight to do my differentiation here. So dy by dx is equal to 3 multiplied by the power, which is minus 2, multiplied by x, and I take 1 off the power, so that becomes minus 3. Let's tidy that up. We have 3 times minus 2, which is minus 6. So it's minus 6x to the minus 3, and that is my dy by dx. Now let's look at the second one. We have this horrible looking expression, 3x cubed brackets x squared minus 4x, and it's all over x. So we have to get into a form where we know how to differentiate it. So we want y is equal to, and then we want something in the form of ax to the n, and then we know we can differentiate. If you look at it here, this actually will simplify quite easily because we have two things multiplied up here and we have an x down here. So actually the x in the denominator here will actually cancel one of the x's on the numerator. So what we actually have is that y equals 3x squared brackets x squared minus 4x. We've just divided through by the x. We still can't differentiate that easily, but we know that we can expand brackets. So we could say that y is equal to 3x squared times x squared is going to be 3x to the power of 4, and 3x squared multiplied by minus 4x is going to be minus 12x cubed. So this multiplied by this gives us this, and this multiplied by this gives us this. Now we have it in a form that we can differentiate. We can do both of these separately. They're both in the form of ax to the n. Here a is 3, n is 4. Here a is minus 12, and n is 3. So differentiating, we have dy by dx is equal to, we bring the 4 down, so it's 3 multiplied by 4, x to the power of 4, take away 1, which is going to be 3. The second term is minus 12 multiplied by 3, x, and take 1 away from the power of 3, becomes power 2. Let's tidy this up a little bit. So we've got dy by dx is equal to 12x cubed minus 36x squared, and we are done. So in summary, if you are faced with differentiating expressions which involve maybe indices, and certainly with fractions here, or algebraic fractions here, what you need to do is manipulate them, rearrange them, simplify them, so that you get them in a form such as y equals ax to the n. Once you've done that, then you can simply differentiate as you normally would.